Hello everyone, welcome back to Mr. Lee's Math Class videos. I'm Mr. Lee. Let's talk through the general steps for solving a trig equation. We've already seen some of these in 7.6, but let's just talk through some of the solution methods that might need to be used. You can determine if it's linear or quadratic to determine the solution method, because if it's linear, likely there's only one trig function, so you can solve for it. But if multiple different trig functions are present, you might need to get one side equal to 0 and see if you can factor, or possibly square things as needed. If quadratic form, but not factorable, you could have to use the quadratic formula. You could also use identities to reduce the number of trig functions or get the equation into more helpful form. That's really where the squaring might come into play. So solve for each equation, and again, if it's in degrees, it'll be theta, radians, x. I'm going to go ahead and do, I think A is pretty easy using a Pythagorean identity, but we'll let you work on that. I'll just let you know, as a reminder, remember that tangent squared theta plus 1 equals secant squared theta. But if you need to solve that equation for tangent squared theta, it's secant squared theta minus 1. So you can use it as for some help. Over here, one of the things that you could possibly do is if there's multiple trig functions, you can kind of look at it this way. 2 tangent x over 3 minus tangent squared x minus 1 equals 0. You can get a common denominator. Minus 3 minus tangent squared x over 3 minus tangent squared x equals 0. And you combine your numerators, since there's a minus there, minus a negative tangent squared x will be tangent squared x plus 2 tangent x minus 3 over 3 minus tangent squared x equals 0. Now, one thing to note, the only thing your denominator is really going to do here is tell you that tangent actually can't be plus or minus square root of 3, so that when it squares, you're not dividing by 0. So we have to make a note of that. Just tangent x cannot be equal to plus or minus square root of 3, otherwise we'll be dividing by 0. But otherwise, the thing that actually controls whether or not a fraction is 0 is the numerator has to be equal to 0. So that lets us set this equal to 0 with knowing that. And from here we can factor. So we get tangent of x plus 3 times tangent of x minus 1 equals 0. Which means if two things multiply to 0, one of them has to be 0. So when we do this, we get that either tangent x is negative 3 or tangent of x is 1. Now, one of these is a nice value. It's x, so this is radians. When is tangent of x 1? Primarily, it's pi over 4 or 5 pi over 4, but it wants all solutions, so we're going to talk about this in a second. That's on one go around. Where's tangent x negative 3? There's no specific value where tangent of x is negative 3, so what we're going to do is on the calculator do the tangent inverse of negative 3. Make sure our mode is in radians. And so this is approximately negative 1.249 radians. But these don't produce all our solutions. Tangent repeats every pi. So let's talk about this is negative 1.249 plus pi n. Let's talk about this. Even though there's two solutions over here, pi over 4 and 5 plus pi is actually 5 pi over 4. So you actually always, when you're doing this, technically speaking, you can take any single solution and keep repeating at that interval, provided that it continues to be true. If you want to be sure, you can plug in pi over 4 up there to be sure, because if you plug in pi over 4, it's 2 times 1 over 3 minus 1 squared. 2 over 2 is 1. It works. Plug in pi over 4, you get 2 times, again, 1 minus 3 times 1 over 1. It still works. They both work. You could pick either one. Pi over 4 plus pi n will work. 5 pi over 4 plus pi n will also work. Remember that n is always an integer, and this is how we write it. It kind of looks like a z for the integers, like a thick z. But this is really all the first half of 7.1 is. They deal with these x values and these thetas, and just getting you used to the algebraic interaction with the trig functions to solve equations. The second half of 7.6 will start bringing multipliers inside the trig functions to talk about how it works. So the most important thing that I can talk about here is that solve the following over 0 to 2 theta in all solutions. Tangent x equals 1. We know that x needs to be between 0 and 2 pi. Where is tangent x 1? We just saw it on the last page, pi over 4 or 5 pi over 4. If you do pi over 4, it repeats every pi n. So we have the pi over 4 and the 5 pi over 4, but we also can relate it to all solutions by doing pi over 4 plus pi n. Sometimes it's actually easier to do the all solutions equation and figure out which ones, by plugging in n equals 0, n equals 1, n equals 2, which ones fall in the interval. 0 and 1 in this case fall in this interval. However, if we start with 0 is less than or equal to x is less than 2 pi, and I'm asking about 3x now, I have to multiply all three of these parts by 3. 0 times 3 is less than or equal to x times 3, which is less than or equal to 2 pi times 3. But 0 times 3 is still 0, so 0 is less than or equal to 3x is now less than 6 pi. So when we had x in there, we were just looking for the solutions the first time around the circle through 2 pi. When you toss a 3 in there, you're running 3 times as fast around that circle, which means you're going to make 3 loops of that circle by the time you are done. So what this is going to mean is if you take that pi over 4 plus pi n, you're looking for all of them that are the first 3 times around the circle. So the first time around the circle is still pi over 4 and 5 pi over 4. The second, though, is when you plug in 2, you'll have 2 pi plus pi over 4, which is 9 pi over 4. 2 pi plus pi over 4, or plus the 5 pi over 4, is 13 pi over 4. And the third time around the circle, would be 4 and 5, we're adding another 2 pi to this, 17 pi over 4, and 21 pi over 4. One time around the circle, 2 answers, but the same answer for all solutions as 3x. 3 times around the circle, 3 times as many answers, but again, the answer for all solutions is the same, so it's really about seeing which ones line up properly in that ratio that you're looking for. Similarly, if x is between 0 and 2 pi, well, x over 2 has to take x and divide it by 2, which means the range of values also gets divided by 2. Here, you're actually looking for only values that cover the first half circle. You're going half as fast, so by this time, this one's covering 1 rotation around the circle. This one's covering 3. You've only gotten through a half, which means still the same solution for all solutions, but you're only looking for it in the first half circle. So that means only from 0 to pi, and you only have pi over 4. Now, why not 5 pi over 4? Because if 5 pi over 4 was equal to your x over 2, when you double it, it's now 10 pi over 4 or 5 pi over 2 is equal to x. Suddenly your x is not in the interval for x anymore. 5 pi over 2 is bigger than 2 pi. So in general, it's sometimes actually easier to do all solutions first and then do the other solutions from there, but you can always work backwards from there. It also actually helps us to see how this actually works. Now you may actually be saying, wait a minute, what about this? Well, this one is x is equal to pi over 4 plus pi n, but the inside now is 3x equals 5 pi over 4 plus pi n, and this one is now x over 2 equals pi over 4 plus pi n. So even though the right side stays the same in this equation, because they're all the same, 3x is now equal to all of those things. 3x, x will be equal to these. Here, 3x is equal to each of these individuals, and we'll see how we deal with that in the next video.